Hello. Okay, I am re-recording. I may reuse some of the portions from before, but I was not particularly happy with how I explained it the first time around. After I watched the video, I was like, I don't think I talked about space-time, and I did not um talk about I didn't draw it out. And yeah, I wanted to do it over so you could see I have notes from before that I doodled out during my previous explanation, but I didn't like that one. So, and I kept getting cut off every single few couple minutes, and when you're explaining something complicated, it's probably good not to get constantly interrupted. So we are going to do problem 3. And problem 3 is reverse K groups. Um, and the prompt is, given a linked list, write a function to reverse every K nodes where K is an input to the function. If a linked list is given as 1, 2, 3, 4, 5, 6, 7, 8, and null, and K equals 3, then output will be 3, 2, 1, 6, 5, 4, 8, 7, null. So I'm gonna erase this and redraw it. I think that's okay. And I hear my dogs coming, so they may start barking, and I may be interrupted again, but I will do this quickly. Um, yeah. I'm not gonna promise perfect drawings. As you can see, the one I just erased doesn't look great. But yeah. I'm also going to be more conscious of space that I use. So K equals 3 and input. So this is our input 1, 2, 3, 4, 5, 6, 7, 8, and null. And this is our linked list. So I am doing a recursive method with a call stack. Which is obviously more space, but we'll talk about that later. I'm gonna erase this, even though I don't necessarily need to. I'm actually glad I have typed this out before, like I was my decision to type out, because I could write on all over this and the point and explain more clearly what we're doing, because I think this is quite a complicated problem, and we're gonna do it the recursive way, which is gonna make it even more difficult to explain. So hopefully I do a better job. So I think what would help is if we had, I don't know about if we had, I don't want to talk about it now, but I think because I forgot the last video to explain, this approach has a time complexity of it was a linear time complexity, and space is also linear. I think it's a little confusing because I'm like, we're not making any special data structures, but we have a call stack behind the recursion. So, but yeah, linear time uh, and space is linear as well. And so in this problem, what it would be, so we are essentially just reversing a singly linked list. It just happens that this is a linked list that's like kind of glued together. So what we're essentially doing is just separating like this, um, and then reversing every K group. Um, and yeah, I should draw this better. So we are reversing every K group, and then after we reverse every K group until we hit null, then we go back and kind of move the head pointer to the helper head thing that gets. It'll make more sense what I'm explaining. So these are K groups. And the special case for this is if it's less, I'd explain in the code, but if it's like K group is 3, but we only have 2 inputs, we still reverse 2, so the goal output is 1, let me write the goal output. Well, I'm going to erase this because I think it's really distracting, and I need to redraw a lot of arrow pointers, so yeah. That was what screwed me up the first time. Was I like it was like arrows going all over the place and like this, and I was like, I don't know what I'm reading. And I feel like this is kind of good practice because yeah, linked lists could get really hard, and this is an example of like I think a pretty tricky uh linked list problem because there are so many things that you have to care for and make sure that is like kept properly, and a lot of like cases where you go, oh, what if this is blah, blah, blah. So it's a little tricky, but this is our goal output, and then we're gonna have 7 and turn to null. So as you can see, we have reverse k um, from 1 2 3 to 3 2 1, and this group from 4 to 5 to 6 5 4, and the last group of 7 and 8, only 7 8 to 8 and 7. Some exercises say to leave it as is. We are reversing ours, which is why that impacted this part right here. So, what was I doing? So yeah, now here's the code. I feel like I misexplained something. I feel like I forgot to left something out. But yeah, we're just reversing linked lists and doing like a all the way through and then tying it together. So we are going, so this is our base case. In this recursive code, we're going to define reverse k with the linked list and k as input. And then we're going to write, so this is our helper function. And this part right here is our helper function. And we are going to, I'm skipping ahead, sorry. So we're going to say with an input of head node and k. So we are going to say if there's no head node, then we're just going to return the head node. So it means that we don't have, this part means if we don't have anything more to like reverse or switch, no more pointers, no more nodes to whatever, just return the one thing we have. So when it hits null, just return. If there's no head node, just return the head node. If yeah, you know what I mean. I explained this so much better the first time this part actually. But yeah, so and then we're gonna assign current to. I'm gonna write this down. We assigning current to head node. Oops, there should be an underscore here, I believe. So yeah, we are going to, so number 1 is current right now, and then next is this number 2 is next, and we're going to initialize one at I at 1 because unlike, and this confused me at first, unlike a array where it starts at 0, linked lists start at, like if they say 1, it's 1. They don't do the 0 index thing. So 1 means we're starting at the front, which is the head node, which is current or cur, and so while there's, so in this while loop that we are using for our recursion, we're doing while there's the next node and while I is less than 3, because we need to increment I in order to keep under the k. So we know every k group we reverse and then we kind of start over in the next group, so we don't confuse ourselves. So we're going to assign temp we're going to assign next, which is 3 to temp. We need to save this because we will be moving it. And then we are going to, as you can see, I've scribbled all over this, but we are now going to move the pointer here. And I'm going to Control Z because otherwise there's going to be many pointers and it's go all over the place. So usually I'm just going to Control Z. So we're just going to move. The next line says cur equals next dot next. So now we have 2 pointers. The 2 is going to 3 and the 1 pointer is going to 3. Yeah. And then the next line is cur equals next, which means that we are incrementing cur to 2 and next to 3. So in the end, it would look like this. Cur, oops, and next would all land here. Okay, so you're essentially reversing these two pointers in the group as we increment on. So the next one, since we incremented I, the next one is going to move temp over here. And the whole process starts over again. So essentially what we did was this, like that. And then we kind of just start again, except we have incremented one forward. So we could kind of run through it again. Oh, and this would become 2. I would become 2, like that. And then while next, so there's next, and I is still less than k, because it's at 2, not 3. So then we go one more time and go temp is, F4 now, and current is at 2, and the next of current is the old temp, which was 3. So we basically moved on one forward. And then we're gonna increment I, and we're gonna turn it into 3, and which makes us eligible to leave the while loops, which means we go down here, right here, out of the while loop. And this is the tricky thing, is that so we are now calling our helper k function with the next node and k, and then we are going to go through this again, and then we're going to assign it to head node.next, but we are returning current because current will be the head node, the head of the linked list that we return. So we need that returned. So essentially, we chop what the code does is we chop up sort of these this linked list into 3 chunks, or into k chunks of simple reversals, and then after we're done, so let's say the interesting part is, like, if the current becomes here and next becomes here, and temp is now like here or something, then or there's no whatever, so it, how do I say this, so if there's no, so yes, if there's no next, then it doesn't really enter the while loop after 8 and 7 has been switched. So then we call, since we call this recursively, then we use this code to join up the heads, or what would be the new heads, or what would be the next, so head node.next, like, yeah, then it would be joined up with the, how do I say this, so 1 would be connected to 6, and 4 would be now linking to 8, and then we have a complete whole reversal of a reverse chunk of lists instead of 3 separate, whereas so like this would go, so this would have gone last, you know what I mean? So and after everything has been reversed, then we point it to the new head node of the newly reversed chunk of linked list. So this is what I kind of drew to kind of, I know it's terrible, all the arrows, but essentially we are saying this part, we're saying whatever the reverse of this is, we're going to make the next of the head node we're gonna save it as the reverse of the head node. The head node of the reverse is this, and we're going to return the linked list afterwards. And this part I already wrote it down, but this is the call. Now from here we're calling the function. So like 3 would oh, I forgot to erase this, my bad. So all these pointers have sort of been reworked. Just it's a lot of moving parts, so I don't know how to illustrate that on something like this, but yeah. So we have to reverse everything first. The order is really important here. We did reverse everything first, and then we could go, okay, the head node dot next is going to be the pointer. It's going to point at the pointer, and then yeah. So I don't know. I did not like this problem because it was just so hard to illustrate. Okay, that's how the solution works. Obviously, this is not all of my code, but I decided with the recursive. I went with the recursive method because I thought it would be. I think it's easy. Oh, here comes my dog. Okay, I'll wrap it up. I think it's. Sorry about that. I'm just gonna wrap it up. Okay, bye.